After the break, yes, now the following video record is about the same projection, saying the same what I mean. See this worksheet number 10, and previous video record, well, studied on this projection. It is the view of that object, this golden object. It is in the pictorial drawing, can be seen what it is. It looks like made of golden, okay, gold. Yes, well, the previous video record just was to demonstrate the things one more time. For the ones they have two tangent points and the ones they are circles or circle arcs. In applying the classical method, what are the things to do? And also for the first time to demonstrate after, of course, the education stage on the cases. Well, what is the case? There are some circle arcs and they have only one tangent points. Or say piece of straight lines, they have only one tangent point. Well, what is the thing to do in such a case for having such a part on a view in applying classical method? Well, these are all subjected and answered on this specific example. Applying classical method, well, studied on this projection in 2D AutoCAD environment. Now, this video record is about the things to do for outputting this image. This is the selected view from this worksheet. It is relative to the others, difficulty levels of the others, can say that this is the most difficult one to deal. Okay, applying the modern method, gonna study on it. Okay, then start. Well, I have the screenshot in picture format. For having this view in AutoCAD environment in the memory of my computer. Yes, I'm going to use that screenshot for my convenience as if I had two displays. You know this technique. Okay, I open my template. Okay, and then slide it to the side of the screen for having such an empty space, and then paste the screenshot. Where is the screenshot? Well, the screenshot is in the memory over there. Right click, say copy, and then paste here in construction layer. Why not? Paste. Twice clicked enter, press enter, and then make it more suitable in size. And then yes, the selected method is the modern method, and to the end of the previous video record, as I said, if you ask me which method is recommended for having this projection in using 2D AutoCAD, I said the modern method is recommended. Okay? Because in applying the classical method, there are 4 tricky things to know for creating this tangent line, and for having this part of the projection without drawing the construction lines, impossible to find the center. I mean, there is no magic in AutoCAD to click, okay, push button to click to create such a circle arc. Need to draw constructions, but in my modern method, yes, can say that we have the push button to click, okay, for having this boundary in the end. start and see how. Okay, well, I'm going to have the projection, the visible parts of the images of the visible parts of the object on the view, in other words, correspondingly the visible lines in visible layer 3. I selected that layer, and in modern method, applying modern method, if there are some circles on the projection with the given size and the available location dimensions, then first create them. Circle creation, and then here I'm going to create 3 circles for having this group on the projection arbitrarily. Okay, and 1 more circle I can create it in the same layer, but thereafter I can shoot it to the correct page, because it is a hidden circle. 2 more circles, this and that, yes, to have this part of the projection, and 1 more circle to have indent this circle arc. It is at a lower level than the others. Okay, then the end of the first stage. Save the file. Obey to the recommendation. For the first time, selecting Save As option. And then check the address. It is correct. And then generate the name for this file. Surname, ID number, if there is section number, write section number, and this is the example selected from worksheet. WS means worksheet number 10, and the identification of the view you see is 6. So I'm going to use this abbreviation V6, and the selected method is modern method. Date of creation or drafting is the 17th of April 17. And then second stage, co-centricity constraint. Yes, we know that the circles in this group, in that group correspondingly are concentric circles. Well, by the way, without forgetting, change the layer of this circle from the wrong to the correct. You know how? Yes, now it is in the correct layer. And then modern method, co-centricity constraint. You know how? Parametric ribbon, this button, clicked, and then, decide to keep the center of the circle, one of the circle, at the existing place, and then indicate it first. It's not so important which one, but say I decided to keep the position of this circle, so I indicated it first, and then the other. Reclicked this one first, and then the other. Yes, now these are concentric. Apply the constraint for the second group. This and that are concentric, and then click on Save button. The next stage is anchoring stage, dimensional constraining stage. We know linear distances, okay? In Cartesian coordinate system, we have their relative locations. Linear distance, indicate this one, okay? While you're seeing the highlighting at the center, this means you can indicate center, and then indicate the other, see the highlighting, click, and then the distance between them in the vertical direction. So to measure and input the constraint, move the cursor to the right or to the left, click, and then write the correct value from the projection available one on the sheet. We know that it is 10. Press enter. The horizontal direction distance between them is this plus that 85. Okay, from the center of this group to the center of the other group, distance is equal to 85. Yes. Now the second center with respect to the first is at the correct place. How about the center of this circle? Dimensional constraint. From the center of this to the center of that, distance in the vertical direction, is 25 plus 25 is 50. Okay? And the distance from the center of this to the center of that is this plus that, 85. Okay? From here to there. Or from the center of this to the center of that, distance is 0. Which one you like? Okay? It is 85. That is the end of the anchoring stage. Save the file. And then the next stage is sizing. Input the constraints for the circles. Okay, this group we know their diameters. Diameter inputting button. Diameter of the hidden circle is equal to 40. Diameter of the visible circle, one of them is 40. Yes, now they are coinciding. And the diameter of the other one, diameter inputting button is this one. Click. Its diameter is 20. Yes. Well, the second group, diameter of the inner one is 20. Diameter of the outer one is 40. And the radius of this one is 10. Yes. Save the file. And then here I'm going to study on the circles, circle arcs, tangent circle arcs. But at the creation stage, those going to be full circles. They have two tangency relations. Okay, if the method were classical method, I would say that, yes, use this tool, 10-10 radius. But in applying modern method, no, it is not the tool of modern method. The approach is different. Create the circle first arbitrarily. Well, at this site, I created such an arbitrary circle. My plan to use this circle for having this boundary at the end. Size it using parametric ribbon, tool of parametric ribbon. Its radius is 10. Click 10, press enter. And then check after sizing it, whether it is still at the correct site. Relative to the circle, the centers of the available ones to those it must be tangent are at the outside, at the correct side. You see, center of this is at the outside, center of this is at the outside of the area which is bounded by this circle. So can input the tangency constraint. Otherwise, I will move the circle to the correct side. Tangency constraint, and then indicate the circle, indicate that circle. Yes, these are tangent. Reclicked. Indicate the circle, indicate the other circle, tangent. Trim the further extension. No, never. Be aware, software is AutoCAD, old generation software, and trimming is not allowed at intermediate stage, because if you trim this circle at that stage, then, well, the associated constraints will also be trimmed, deleted. And the next stage, you may find the already drafted one as if exploded, because they lost their constraints. So do not apply trimming process. Continue. Create one more circle. Okay. Here, arbitrarily. And then, well, in my consideration, this circle is to have this boundary in the end. So accordingly, size and position. parametric ribbon radius. Indicate the circle and its radius is equal to 40. And then checked after sizing it whether it is still at the correct side. I see from this projection the center of the available circle, this is the available circle, to this circle that arc must be tangent, is at the inside. Where? Saying inside, I mean see the region bounded by this circle arc, and this region is bounded by this, so it is inside. Okay, the other side is the outside. Well, the center of this is at the inside, center of the other circle is at the inside. Check whether it is the same case right now. Well, I think no, it is not. Say the center of this available circle, you see, is at the outside. So, well, if I input tangency constraint, since now this circle relative to the available one is at the wrong side or vice versa, then, well, this circle will be tangent to the indicated one, the other one, at the wrong side. So, you know, in such a case, the thing to do, apply move process. Or, this may be easier, make a click at any point along the circle. Its center point will be highlighted with the gripping point. It is gripping point. Grip it with a click and then move the cursor. Of course, since you hold it, then together with the cursor, you can drag it to the correct side. Or apply move process. Okay, along the edit home ribbon in edit panel, can find home, say this move facility button, move process button, click and apply. But I think this is easier to apply. It takes shorter time. So, well, this circle is at the wrong side, but if I move it to here, it is gonna be at the correct side. Yes, you know, to be able to prevent software from snapping, I'm keeping snap enabling button in off status. So since it is off, without any difficulty, I apply gripping method and manage to bring it to the correct side. And then apply tangency constraint. Clicked on this button and then say that this circle and that circle must be tangent. Yes. Clicked on this. This circle and that circle must be tangent. Great. You see now managed to have the necessary circle over here after trimming to find this boundary, to have that boundary. Okay, another circle has two tangent points. Well, it is this boundary to have, after trimming of course, created, circle creation process, and then, well, created. First arbitrarily, and then dimensional constraint radius indicated. Its radius is 95. And then check whether the circle you found after sizing at the correct side. No, you see the centers of the availables are at the inside, but right now these are at the outside. So I need to move this circle to have the centers of the available ones at the inside. Now let me apply not gripping technique but move process. Okay, which one you like. Start the process with a click, indicate the circle, press enter, and then make a click at any point inside the circle, and then yes. Not drag here in this case. In applying gripping method, in using gripping method, left clicked on the center, gripping point which is at the center, and drag the mouse. But here applying move process, indicate a point in the area with a click, and then do not hold the left button. Remove the finger, just move the cursor. and well, bring it to the correct side. Now if I locate the circle at such a place, then the centers of the available ones will be at the correct side. Okay, great. Then the rest is easy cake. Tangency constraint, parametric ribbon, tangency constraint, and then indicate the circle, indicate the circle. Yes, these are now tangent. Reclick, indicate the circle, indicate that circle, tangent. Trimming, never. Well, since trimming is not allowed here, you see at the trimming stage, it is going to be a challenge for me. Well, you see, when I make zoom in, I see a few circle arcs. Which one is necessary, which one is unnecessary? Well, need to be more careful at the trimming stage because of the existence of such an interference. Okay, save the file. Don't forget after each stage. Well, if the dimensional and geometrical constraints, constraining symbols, making the screen crowded, then you know can hide them. Hide all, hide all. And then, well, see how such a tangent line is created. Okay. And then how it is inclined. Well, here I'm going to use this priority. Instead of creating a dummy line and using that dummy line after making it horizontal as the reference for inputting this angle, well, first let me create this horizontal boundary, and then with respect to this boundary can incline that tangent line. Okay. Create the line first arbitrarily. Well, I know that it is terminal point. This terminal point, I know it is coordinate value is at a lower level and at the right hand side with respect to the center. So while creating that line, indicated the starting point at the correct side. Not here, but there. If you do not pay attention that the point is at which side, then it is gonna be maybe necessary to apply move process to bring that point from the wrong side to the correct side. So, well, now my cursor just ready to make a click to locate the to indicate the starting point of the line, end point of the line. It is at lower level and at the right hand side. So click and then create the line. I don't know the length of that line. For being safe to side, say furtherly created as furtherly extended. Although I know that it is a horizontal line, but at the creation stage created as if inclined. Okay. Press escape button and then the rest. Input the constraint. First one of them is geometrical constraint. It must be a horizontal line. So parametric ribbon, horizontality constraint, okay, and input. Yes, now it is a perfect horizontal line. The other constraints, well, to bring the terminal point of this line to the correct place. It is 30 units away in the horizontal, 25 units away in the vertical direction. Dimensional constraint. From the center of this to the terminal point distance is equal to 30. Yes. In the vertical direction, linear, center to the terminal point distance is equal to 25. Yes, now manage to bring this terminal point to the correct place. Okay, and I have the horizontal line. And then, well, see, remember in applying the classical method for having such a line, it has only one tangent point. There are 4 tricks. Change snap configuration, trick 1. Have at symbol, trick 2. And then, well, clicked on angle tab. It is the key Well, in the structure of keyboard on which there are less than greater than symbols, it is the third trick. And the last trick, input it is inclination angle as measured with respect to a horizontal line which passes through the tangent point in the counterclockwise direction. The angle has been calculated and measured, and so correspondingly input in the counterclockwise direction. These are the tricks. But in creating such a tangent line, okay, there is no trick. No matter, not a matter whether the line has two tangent points or only one tangent point. Well, create the line at the correct side arbitrarily. Okay, greater than it is, longer than it is order. Press escape button and then the rest. Parametric ribbon, constraints. Tangency constraint, indicate the circle, indicate the line. That is it. It is tangent. The other constraint, it is inclination angle. In classical method, no need to calculate the angle with respect to the line which passes through tangent point and in the counterclockwise direction. But in modern method, directly input the angle. Click on angle inputting button and then indicate this boundary line as it is reference and indicate this line and move the cursor to have the angle as measured in the same sense. Okay, click, and after the click into the box, write the angle 60. That is it. Now you see this line as it is required. Perfect, correct. Okay. After trimming, of course, it will find its other terminal point and also the tangent point at the correct place. But here, trimming is not allowed. Okay, to be able to create this boundary, in classical method, what we have, construction lines. About this point, create circle. About the center of the available one, create that circle. But in applying the modern method, no need, say. Well, to have in the end such a circle arc, create the circle arbitrarily. At this side, I know. Create the circle arbitrarily and then input it is parameter. Radius. Click on this button and then indicate the circle, click, and the radius is 20. Okay, after sizing it, check whether it is still at the suitable side, correct side. Yes, the answer is yes. And then, well, the constraint, one of the constraints for this circle is it is tangency. Clicked on this button and then say that this circle, that circle are tangent. Okay, now these are tangent. The other constraint, that circle is to pass through this terminal point. Yes. In other words, one of the points of the circle is to coincide with this terminal point. Coincident constraint. Clicked on this button. Okay, indicate the terminal point and then indicate this circle. But when you know the trick in AutoCAD, if we bring the cursor to the vicinity of a circle to indicate one of the points in the circumference along the circle, then AutoCAD using its default configuration will be ready to its center point for our click. You see right now cursor is in the vicinity of the circle and you see the highlighted point is the center of the circle. My purpose is not to coincide the center. Coincide a point along the circle. You know the trick. It is the only trick to know in applying modern method for having such a circle. It must pass through a certain point. Is that before indicating the circle, click on down direction key of the keyboard and select the option. Actually, the existence of this tiny arrow within the box, this train, it is for reminding us that here at this stage there is an option list. In the list there is only one option, select object option with a click. This is to say that not the center but a point along the circle is to coincide. Click and then indicate the circle. That is it. You see, circle found at its correct place. Now a point of the circle, one of the points of the circle, you see passing through the terminal point of this line. Okay. Then great. Almost finished. Try to visualize in the mind. Say that you trim the further extensions and then check whether the remaining part gonna be at the center of the paper. In my case, the answer to this question is no. So, you know the thing to do. Cut and paste. Home. Clicked on Edit. Option along the drop-down menu bar and select Cut option. And then respectively following the paste. Or you may use the tool in clipboard panel. Cut, start the process. Okay, using windowing, select the things, press enter, and then click on paste. And then at this stage, making such displacements, okay, trials, try to bring the projection to the place at which after the trimming stage, then can find the projection as centered. I think this place may be indicated. Click your mouse. And then the rest. Trimming. Hide the symbols for the convenience. And then, be careful. At the trimming stage, I don't want to trim hidden line. Visible and hidden circles are coinciding, so I'm going to use locking technique. Okay, lock the layer in which I have the hidden line. You know how. Now, I prevented software from trimming on the content of that layer. Okay, start trimming process. Now, trimming process is allowed because we have all the entities and the projection is at the correct place. Then can trim. Press enter and then using windowing method indicate such a part to delete the visible part of the coincided circle. Okay, and then I know this part of the horizontal line, okay, till this corner point is further extension, and can say same thing for this inclined line. Okay, and here carefully apply trimming process. After this tangent point, you see the circle arc, it is radius 95, approaching to this circle and then touching to the visible and also the hidden circle, and after this touching point, contact point, the rest is to raise. You know, I'm going to use my technique. I deleted the first segment and then follow the circle and then zoom in, zoom in, zoom in. Yes, follow the circle and then circle approaching to here and then being tangent. I think, yes, this is the last segment of that circle. I hope I deleted the correct part. Okay, continue. Zoom in, zoom in. Now this straight line, okay, after the tangent point is the further extended part. Okay. Now this circle arc, this part, this one, and then zoom in, zoom in. Well, I see this is approaching, touching, and then the rest. Which part? I think this part is to erase. Yes, I did it correctly, I think. And then this part, yes, we have no such a thing. We have no this one, that part, this one, and this part of the circle. I think I applied trimming process satisfactorily. Press escape button, finish, and I know this is just the part to delete. Yes. Great. Manage. And then lastly, show the axis of symmetries. Well, here to be able to indicate the center points, I'm going to use right now the classical snap facility. Clicked on this and then check whether for center points there is an enabling. If not, then make a click here and enable software for your indication. Okay, start the symmetry axis creation process, center line cross, and then well, thanks to snapping can indicate the center and then indicate the midpoint of the outer circle. Okay. Similarly, start, clicked on this, and then snap the center of this group, and then if you want, you may type the diameter or indicate the midpoint of the outmost circle or outer circle, diameter 40, and then have the circle, have the axis of symmetries in the correct order. Yes. You see, well, much more easily reach to the same end via applying the modern method. Modern method is recommended for such a geometry. And finish the drawing, so I do not need to keep this screenshot in the environment. Select and click delete button. And then finally one more time save the file. Okay. Dear students, finish studying on that projection one more time, applying the modern method. Well, have a break. After the break, I'm going to, well, demonstrate the things to do for creating the model of the object in Inventor. I'm going to skip the fulfillment. It is about model creation in AutoCAD because there is no new thing to highlight. There is no new thing to educate you on model creation part in AutoCAD. But to be able to demonstrate that in Inventor, yes, well, if there is an AutoCAD file already drafted, well, can create the model of the object easily, much more easily. Okay. One more time, I want to demonstrate it, how an AutoCAD file can be imported. And the following video record, I'm going to, well, create the model of the object purely using the tools of Inventor. Only the tools of Inventor. Okay, there will be, after the break, in sequence, 2 more video records. Okay, these are to demonstrate how the model of the object is created. Okay, bye-bye.